In this lesson, we're going to be filling out the whole unit circle now that you have the tools to do so. We're going to be using colors to kind of see patterns. So we're going to start with the basic circle setup. We're all doing this with the same color, so we need black. So we're going to label our X and Y axis. And the next thing is we're going to write quadrants. So this is quadrant 1, 2, 3, and 4. And I'm not going to be explaining too much the stuff that we've already done. And the other thing we want is we want to state the positive and negative signs of each point that are a point that is in each quadrant. So this is positive X, negative Y. Next, we're going to label the quadrantal angles in degrees and radians. So my quadrantal angles are the ones that fall on the quadrant lines. And each of these is a 90-degree turn, so we know they're multiples of 90. For radians, we know the whole unit circle has 2 pi radians because that's how many radii fit around a circle. So half of that would be pi. Half of pi is pi over 2, and you can use that line as a fraction bar, it's kind of nice. And then in between 1 pi and 2 pi is 1.5 pi, which we write as 3 pi over 2. Next, we're going to label the points where the unit circle intersects the axes. So this was something we did on the very first day at the beginning of the lesson, and this is just knowing the radius of the unit circle is 1, and then using directions for X and Y to label those coordinates. We are going to highlight the x-axis, which I'm going to attempt to do up here with a highlighter, but I don't think I have one. So if you have something, let's just see if I can do this. You just want to highlight the x-axis. Okay, that works. Just to say everything is going off the x-axis. Notice I'm not highlighting the y-axis. So the next thing we're going to do is we're going to label the rest of the degrees, which is also something that we did the first day. And we're going to be using colors. So I'm going to use blue for everything that's related to 30 degrees. So usually I would just go in a circle, but the ones that are related to 30 degrees, I'm basically saying all angles that are 30 degrees away from the x-axis. So this is 30, this one is 150, I have 210 and 330. Okay, so those are just measuring 30 degrees away from the x-axis. I'm going to use green for everything that's 45. So this is 45. Here I would do 180, so here's 45. 180 minus 45 is 135. 180 plus 45 is 225, and then this one is away from 360, so I put in 315, 360 minus 45. Lastly, we'll do the 60, so this is red, so I have 60, this one is going to be 120, so these two from my x-axis have that same measurement. 180 plus 60 is 240, and 360 minus 60 is 300. So my degrees are done. And as I drew those little arrows, we were using something called reference angles. So a reference angle is an acute angle used to find trigonometric functions for larger angles. And the way we calculate it is the distance from the closest x-axis. So if I'm talking about, for example, I don't want to break too much on the unit circle because we're going to have a lot going on here, If I'm talking about 120 degrees, its reference angle is 60 because it's 60 degrees away from the x-axis, 60 degrees away from 180. If I'm talking about 225, its reference angle is 45 because it's 45 degrees away. So these little lines in here, arrows, measure out reference angles. So the next thing we're going to do is start to follow the rest of the radians, which is new. And we're going to go back and I'm going to use the same colors. So I'm going to start with angles that are pi over 6 away from the x-axis. So pi over 6, we know from the previous lesson, is our radian measure for 30 degrees. So anything in blue has a reference angle of 30 degrees, or in this case, we could say pi over 6 radians. So the way we do this, and I'm going to do an example over here. When I'm working from quadrant 2, I'm saying how far away am I from pi, right? Because quadrant 2, we're measuring from pi. And if I'm going into quadrant 2, I have to subtract my angle. So this is just like we did 180 minus 30. We could do to get the 150. We can do pi minus pi over 6 to get the answer for that angle in radians. So I need an LCD, so this is going to be a 6 for my common denominator, and this is 1 pi over 6. So 6 pi over 6 minus 1 pi over 6 is 5 pi over 6. So this angle measure is 5 pi over 6. If I'm going into quadrant 3, I'm going to do the same thing, except I need to get bigger than 180, right? Just like I added 30 to 180 to get 210. I'm going to add pi over 6 to pi. So 6 plus 1 is 7, and we get 7 pi over 6. As I move down to quadrant 4, this one I have to build off 2 pi, right? That's where my arrow went in over here. So I'm going to do 2 pi minus pi over 6 because we're going smaller than 2 pi. So 2 pi, if I get an LCD, I'm going to multiply by 6 over 6, which is going to create 12 over 6. Okay, so I can kind of slide that in because 12 and 2 have the same first digit. So 12 minus 1 is 11 pi over 6. So over here, for my 330, I have 11 pi over 6. And you'll notice all of those angles with a reference angle of pi over 6 have denominators of pi over 6, which is really nice, right? Because then we can kind of see how they match up together. So we're going to move over to the 45s, and we already did the 45s in a different way, but we're going to think about our reference angle method. So I know 45 has a radian measure of pi over 4. Moving on from here, if I'm at 135 and I want to get into quadrant 2, I'm taking my pi, which is over here, and I'm subtracting the pi over 4 because we're going smaller. So now for an LCD, we're going to get 4 over 4 here. So I get 3 pi over 4. And the idea is that you wouldn't have to write out these fractions. So to go into the third quadrant, I'm taking pi and adding pi over 4. So 4 plus 1 is 5 pi over 4. Over here, if I have, and I'll write this one out, this one is a little trickier, just to work with the 2 pi. So if I subtract pi over 4 from 2 pi, I'm going to get an LCD, so this is going to become 8 over 4, which gives me 7 pi over 4. So moving on to the next angle, we have our 60, which we know is pi over 3. And I'm going to start to do these without showing the full work for them. So you'll also notice a pattern in the second quadrant is that the numerators of those radian measures are 1 smaller than the denominators. And that's because I'm subtracting 1 of whatever the fraction is. So here, if I know I want it over 3, because it has to match this denominator, right, that's going to be 2 pi over 3, because 3/3 minus 1/3 is 2/3. If I look in the third quadrant, I notice my numerators are 1 bigger than my denominator. So this is going to be 4 pi And I realized I have to use backwards with degrees for radians. I'm not too worried about that in terms of fixing it, but yes, I did put those corresponds. Over here in the fourth quadrant, I have 1 smaller than double. So 11 is 1 smaller than twice 6. 7 is 1 smaller than twice 4 because it's 1 smaller than 8. So if I put a 3 on the bottom here and I go 1 smaller than twice 3 is 6. So this is going to be a 5/3. So those are your degrees and radians. And just to not make the video too long, we're going to do the last thing, which is filling out the points on a separate video.